Hello, students. Now let's begin the discussion of section 1, future value of chapter 4. Okay, now let's go to the slides. Okay, now we know the money has the time value, and we know $1 today is more valuable than $1 in the future. We want to know by how much $1 is more valuable than $1 in the future. Or in the other words, in order to get $1 today, how many dollars would you like to pay in the future? Generally speaking, we want to establish a quantitative relationship between today's dollar and the future's dollar. We begin our discussion with a game. Okay, now, you're going to make your decision by intuition. Now you have two options. Okay, you can choose you can choose $100 today. And the option 2 is, you're going to receive $100 in the future, or you're going to receive $100 that will be you're going to receive $100 3 years from now. Okay, which option do you prefer? Assuming all other things are equal. Of course, because we know money has the time value, right? And we know, $1 today is more valuable than $1 you expect to receive in the future. I think, most all of you would choose the option 1. Okay, you would like to receive, you prefer $100 today. Okay, I think, the answer in this slide is pretty simple. I'm going to make the situation a little bit complicated. A little bit more complicated. Okay. Now you have two options. One is, you are going to receive, you receive $100 today. And option 2, you expect to receive, or you are going to receive $135 in 3 years, or 3 years from now. Now you have these two options. Which option do you prefer? Assuming that all other things are considered. Okay, usually, some students prefer option 1. Some students prefer option 2. Okay, there is no right or wrong answers. All answers are acceptable. Okay, it depends on your answer, depends on your appreciation of the time value of the money. Okay. This is not the point for this game. Now let's look at next. Now let's move on. Suppose that in option 2, you will receive X dollars. X is a notation. X represents any number of dollars. What is the number of X that makes the two options indifferent to you? In the other word, how many dollars do you require in option 2 so that these two options are equal to you in terms of value? Here, the two options the two options are indifferent to you, means these two options have the same value to you. Okay, and of course, yeah, some students may answer, okay, $135. Some students may answer $200. Some students may answer $1,000. Yeah, in the history, yeah, there were many answers. Yeah, there are. Of course, there is no right answer and there is no wrong answer. Later on, yeah, we're going to know your answer depends on your opinion about the rate of return. Okay, suppose yeah, your answer is suppose your answer is 100, maybe, yeah, $150, right? Anyway, yeah, for every student you have a specific number. Maybe your answer is 135, maybe your answer is 160. It doesn't matter. Okay, now suppose, yeah, we have for one student, yeah, his answer is $150. Okay, that means $100 today has the same value as $150 he expects to receive 3 years from now. Okay, then what is the reasoning behind this answer? What is the reasoning behind this answer? Okay, as yeah, at a practical level, yeah, we can explain this as for these students, he has an investment opportunity. He invests $100 today, and he keeps his investment for 3 years. And at the end, yeah, in the 3 years or 3 years from now, the value of his investment will be growing to $150. Okay, we can explain this. Yeah, we can explain his in this way, right? Yeah, at the practical level. So that means, yeah, no matter what your answer is, okay, on the market you can find an investment opportunity. And if you invest $100 and you keep your investment for 3 years, then the value of your investment 3 years from now would be your answer. Okay. Actually, some students may say, okay, I don't have an investment opportunity. No, on the market there are a lot of investment opportunity. For example, yeah, the most common investment opportunity is your bank account, right? If you have $100, you can go to your bank account. You can deposit your $100 into your bank account. And your bank would offer the interest rate that you will earn on your account. That this is a investment, right? This is a investment, and then the value of your account will be growing, and the growth rate is the interest rate your bank offers to you, or the interest rate you are going to earn from your bank account, right? So yeah, everyone has a investment opportunity. Of course, investment opportunity varies from person to person. Yeah, for some students, yeah, they have a very good investment opportunity. He expects to receive a higher rate of return. For some other students, maybe the most common investment opportunity is just the bank account. Okay, so investment opportunities varies from person to person, and then in a specific investor's mind, his future value would be different from other investors. Okay. Just now I said, future value varies from person to person. However, yeah, on the market, most investors would share some common would share some common investment opportunities. Okay, just now, as I said, right, the most common investment opportunities is your bank account. Is your bank account. So in this case, on the market, most investors would share a common future value. Okay, and because the bank account is the most common investment opportunity, so we're going to use the bank account to explain the future value. Okay, now suppose you deposit to $2,300 in your bank account. The interest rate that you can earn from your bank account is 10% per year. Then how many dollars will you have in your bank account at the end of the year? This is an investment opportunity, right? And now how many dollars will you have in your bank account at the end of the year? Of course, this is the growth issue. Yeah, in this case, the variable that we are going to look at is the value of your bank account, or the value of your investment. Okay, now what is the beginning value of this variable? That is $100. Okay, and then this is a single period growth. The growth rate is nothing but the interest rate your bank will pay to you. That is 10%, right? And you believe at the end of the year, the dollars in your bank account would be higher than the dollars at the beginning by 10%, right? Then we're going to find out the ending value, or the dollars in your bank account at the end of the year. Of course, we can use the formula, right? We can use the formula. If we use the formula, that is very, very simple, right? That is VT, I use VT equals V0 times 1 plus R, right? Raised to the power, because this is a single period holding, so the power is 1. Okay, then in this case, what is V0? That is $2,300. Okay, times 1 plus R. R is interest rate, that is 10%. In decimal, that is 0.10. Right, raised to the power, raised to the first power, that is 1. Okay, then we can get the ending value of this variable, or we can get the dollars in your bank account after you hold your bank account for 1 year. Okay, if you run your calculator, it is very easy for you to get the answer. That is $2,530. All right. Okay. Then in this case, what we can say? Yeah, what we can say? Because this is your investment opportunity, and you expect to receive $2,530. Then the future value of today's $2,300 1 year from now is $2,530. All right. Okay. Now let's look at a 2-year investment process. Here, yeah, the answer is here. Okay, suppose you keep your account for another year. That is, you deposit $2,300 for 2 years. The interest rate that you will earn is the same. That means 10%. Okay. The question is, how much will you have 2 years from now? Of course, yeah, using our formula, VT equals V0 times 1 plus R raised to the second power, right? Because now you hold your investment for 2 years. Now this is a 2-year value growing process. Okay, now yeah, we can calculate, right? V0, that is $2,300 times 1 plus 0.10. Okay, over this 2 year, the growth rate is constant, right? Yeah, every year your bank will pay you 10% interest rate. Okay, and now what is the power? Power is the second. Okay, but do the calculation by running your calculator, then you can find at the end of the second year, your bank account will have $2,783. Okay, then in this case, what is the future value of $23,000 today, 2 years from now? Okay, that is $2,783. Okay, yeah, we can do the same thing for the 3-year investment. Okay, for the 3-year investment. Okay, now for the 3-year investment, of course, yeah, the question is the same. Yeah, the background is the same. Now you're going to hold your bank account for 3 years, and the interest rate that you can earn is the same. That is 10%. Okay, the only thing that is different, yeah, the only different thing is now you hold your bank account, yeah, for 3 years. For 3 years, of course. Okay, we can use the formula to calculate, right? So that is VT or V3. Yeah, the dollars at the end of 30 year equals V0. What is V0? $2,300 times 1 plus R. R is R is 10%, right? That is 0.10, because in this formula we have to use the decimal and then raised to the power of 3 or third power. Okay, it is easy to get the answer, to get the result. That is, I think, yeah, the result of this calculation is $3,061.30. Okay, then what does this mean? What does this mean? Because you expect, yeah, if you have $2,300 today, and you expect to receive, by choosing a bank account, you expect to receive $3,061.30 3 years from now. That means the future value of this today's $2,300 3 years from now is $3,061.30. Okay, and of course, and we can, using this formula, we can find out the future value at the at the end of the 3 year, at the end of fourth year, and at the end of fourth year, at the end of fifth year, and on and on at the end of 100 years. Yeah, if you keep your bank account for 100 years. Okay, so we can find out the future value, and here we would know. To find out this future value is pretty easy. What we are going to do is just use this formula, right? For each year, the change is only the power. Yeah, with this background, your beginning value, yeah, you're going to save $2,300, and your bank will offer you 10% interest rate. Then no matter how long you're going to keep your investment, then you can find out the dollars in your bank account in the future, no matter what years. Okay, so now we can see the formula, the growth formula is very useful. It's very useful. Yeah, we have VT equals V0 times 1 plus R raised to the power of T. Right? If we know the beginning value, if we know the growth rate, if we know the T, we can find out the future value in the future anytime at the end at any years. Okay, this formula is very important. We're going to use this formula in the finance circumstances. So we want to use a finance notation. We want to use finance terminology. Okay, if we use finance terminology, the VT, we would like to use FV, future value, instead of VT. And for the V0, we would like to use the present value for V0. And then 1 plus R is the growth rate. We use the same letter. However, in finance, we have a different name for this R. Later on, we would know. Yeah, usually in finance, we call this R the rate of return, or simply return. Okay. And then the T is the same thing. Yeah, T is the period. It's the number of periods that you're going to hold your investment. Okay. And we call this the future value formula. Okay, future value formula. In our example, yeah, suppose you deposit in our example. Suppose you deposit PV PV dollars. Yeah, PV represents the dollars you invest at the beginning in your investment, okay, or in your bank account. And then you hold this investment, you hold your bank account for T periods. The interest rate per period is R. Okay. What?好好好，行，我在录像啊，行，那我就不跟你说了。好嘞，啊，那就这样。Okay, and then how much will you have T periods from now? We use FV, okay, represents the dollars in your bank account. At the end of the at the end of T periods, then we have this formula. FV equals PV times 1 plus R raised to the power of T. Okay, we call this, yeah, future value formula. Okay, of course, yeah, we can formalize the principle of time value of money by a further generalization. Okay, here your bank account is an investment, right? And in the real world, we have all kinds of investment. You can invest your dollars in your bank account. You can purchase the bonds. You can invest your dollars in stocks. You can invest your dollars in real estate, in gold, in silver, or in artifacts. No matter what kind of investment you're going to do, we can use this formula to calculate the value of your investment at a time point, at a time point in the future. Okay, so that this formula can be used to describe any investment process. This formula is very important. Now let's have a further look at this formula. Okay, again, first of all, let's clarify the definition of variables in this formula. Okay, first of all, let's look at the T. T is a time, yeah, measures a time span. This span is measured by the number of time periods. Okay, here time periods, the time periods could be measured by month, by year, by quarter, whatever time you need. Okay, and of course the number of T defines a actual or imaginary investment process. Okay, and this investment, it could be an actual investment process. That means, yeah, you invest in the past. Okay, and now after you hold your investment, now you want to know how many dollars you have in your investment. Of course, yeah, this this time span could be an imaginary investment process. Yeah, you invest a sum of dollars today. You want to know how many dollars you're going to receive in the future. Anyway, this investment process is a value growing process. Okay. because this investment process is a value growing process, and then what is the growth rate? So R is the growth rate per period. In our example, right? You have a bank account. In this example, the interest rate per period is the growth rate. Okay. This this growth rate, when we use this formula, this growth rate should be consistent with the time unit. Okay. What does this mean? That means if your time is measured by month, and then your growth rate should be monthly growth rate. If your time is measured by year, then this growth rate should be yearly growth rate. And also, if you use this formula, the growth rate should be in decimal. Okay, should be in decimal. Just now, I said, right? This formula, future value formula, describes a value growing process. However, it doesn't mean growth rate is always positive. Okay, in some cases, the growth rate could be negative. All right. Okay. And then let's look at the PV. PV represents present value. That is the value of investment at the time equal to 0 over a timeline. Or that means that is the dollars you initially invest. Okay. Or the dollars you invest at the beginning. That is PV. Then let's look at the FV. FV represents the future value. That is the value of investment at time equal to T over a timeline. Of course, that is the value at the end of an investment process. That is the dollars you can receive at the end of your investment. Okay. Now let's pay attention to 1 plus r raised to the power of t. Okay, this is a very important factor. We usually call 1 plus r raised to the power of t the future value factor. What can we learn from this factor? This future value factor, represents the future value of today's represents the future value of $1 today's investment given T and R. Okay, if you invest $1 today, okay, and you are going to hold your investment for T periods, and you expect to receive the you expect the value of your investment will be growing at the R and R. Then 1 plus R raised to the power of T is the value of this initial $1 investment. Yeah, it's the future value of this initial $1 investment. Okay. So that is the future value formula, and we have a better understanding about this formula. Now let's look at R is very important. Actually, in finance, R has multiple implications. Okay. Now let's look at Now let's have a closer look at the R. First of all, we know that this formula, this future value formula, FV equals PV times 1 plus R raised to the power of T, describes an investment process in general, right? And also, we know an investment process is a value growing process. Okay, so this is why, we say R is the growth rate. Okay, in this value growing process, R measures how fast the value of investment is growing. However, in finance, we usually call the R the rate of return. Okay, or simply return. Okay, so that is the same thing. Okay, that is the same thing. Rate of return or return are the same thing, and essentially that measures how fast the value of an investment is growing. Okay, the R has multiple implications varying from circumstances to circumstances. Generally speaking, right, we say R measures the growth rate. For example, in your bank account, R is the interest rate. Later on, we're going to know if you invest in bonds, then we call this growth rate, or we call the interest rate that you can earn from a bond investment the yield. Okay, generally, we also we call the R the rate of return, especially if you invest in the stock market. Then usually, then the R is the return on a stock. And the R, sometimes is called the discount rate or compounding rate. Later on, we're going to know, okay? If we know the present value and we want to find out the future value, okay, then we call this compounding process. Then in this case, we usually call the R the compounding rate. In reverse, if we know the future value, we want to find out the present value, okay? And we call this reverse process the discount process. And under these circumstances, we can call the R the discount rate. Okay, sometimes we call the R the required rate of return or expected rate or expected return. As an investor, you require a rate of return. Okay, later on, we're going to have a closer look at this from an investor's perspective. Okay, R does not represent the growth rate of his investment. It also represents the return he expects to earn or he requires to earn. And R sometimes is called the capital cost. From the form's perspective, or from the fund user's perspective, okay, he has to pay for using someone others. From the fund user's perspective, he has to pay for using others' funds, and that is the interest rate he has to pay to the lenders, right? From borrowers' perspective, the interest rate is the cost the borrower has to pay to the lenders. Then, in this sense, interest rate represents the capital cost. So in this case, the R is also called the capital cost. Anyway, in the remaining study, we are going to look at these multiple implications of R so that we have a better understanding of R. Then, before we move on, also I like to discuss how R is determined. The R is determined by the demand and the supply of the fund market or the capital market. Okay, in the economics, we have learned this, right? Interest rate is determined by the demand and the supply of fund on the fund market. Okay, and in finance, now we just look at, from the supply side or from the fund provider's side, how R is affected. R is affected by these, generally speaking, by these factors. First of all, the value of current consumption versus the value of future consumption. If you have $100, you can use these $100 to consume something, right? We call this the consumption. Of course, you can use this $100 in the investment. Why do you do the investment? Because you want to consume more in the future. So the R represents the exchange rate between the current consumption and the future consumption. Okay. If you appreciate current consumption more, then you would require a higher exchange rate. You would require a higher R. Okay. And also, from the investor's perspective, or from the fund provider's perspective, R is also affected by the risk of an investment. Then that involves the second important principle in finance, risk-return trade-off principle. Okay, if you assess your investment has a higher risk, then you would require a higher rate of return. Okay, and then the third factor is the liquidity of an investment. Okay, if you do investment, while you keep your investment, you still need some liquidity. Okay, that means you need some cash in hand, to meet unexpected demand. Okay, liquidity is very important. Okay, and investment, liquidity varies from investment to investment. And of course, investors usually appreciate the high liquidity. Okay, so if an investor assesses that an investment has a lower liquidity or an investment is illiquid, then he usually requires a higher rate of return. Okay, and then the last factor is future inflation, or the inflation expectation in an investor's mind. If you expect there will be a higher inflation rate, then of course you would require a higher rate of return to compensate for the loss in the inflation. Okay, if a lower inflation rate is expected, investors usually require a smaller rate of return. Okay, the opinions about the characteristics of an investment vary from investor to investor. Okay, you have the different opinions about the characteristic of an investment. Okay, then what does this mean? That means you have a different different required rate of return for the same investment. However, on a competitive capital market or on an investment would converge to the average opinion of most of market participants. Okay, so that means on the market, the R on an investment is determined by the average opinion of market, of most market participants. Okay. Now, in the next, we're going to discuss. We're going to see how we can use the future value formula in the real world.